Hello, thank you for checking out Mr. Ware's videos, and today we are looking at half-life and doubling time. Half-life and doubling time. So let me give you the formulas that you need in order to solve these problems. You got the doubling formula, which is y is equal to a times 2 raised to the t over d. And the halving formula, which is a times 1/2 raised to the t over h. Well, the t is going to represent the number of years. The a is going to represent where you begin with. Okay? And that's going to be the same in both formulas. The d is going to represent how often it doubles, and the h is going to represent how often it halves. So let's take a look at a couple of examples. Alright, so here in a lab experiment, 590 bacteria are placed in a petri dish. The conditions are such that the number of bacteria is able to double every 24 hours. How many bacteria would there be after 13 hours to the nearest whole number? Okay, so right there it says double, so you know to use the doubling formula. Any indication that it doubles, meaning you're going to use the doubling formula. I've already got it laid out here with everything that you need. So like I said before, that the a is where you begin. So you're going to begin with 590. The d is how many times it doubles. It doubles at 24 hours. Let me change colors on that. And t is the total number of, well, I said years, but the total number of time that it's going, okay? So what is the full amount of time that we're trying to determine here? So in this case, it is 13 hours. So you're going to plug all of those into the formula. So you're going to plug in your a here, which is 590. You're going to plug in your t. We're going to raise this up to 13. Gotta change colors. And then divide that by 24. And I'm going to zoom in here and show you what happened. So this is what you end up typing in the calculator. 590 times 2 raised to the 13 over 24. And once you do, you get this big huge decimal. And since we round into the nearest whole number, got this 858.8. We're going to take this 8 to the right here, and since it's 5 or more, raise the score, so it's going to be 859. So our answer is close to 859. So yeah, 859. Alright, you can go ahead and pause the video on this one here and see if you can solve this one on your own. Alright, this should be what you get. You should get y is close to 485. Okay, so we took our beginning amount, 150. The number of times is doubled. It's doubled every 13 years. And the total amount of time, which is 13 years, I'm sorry, which is 22 years. And we plug that into our formula, and then type in the calculator, hit enter. Okay, so that's doubling life. Now let's take a look at, let's see, doubling time, I should say. Now let's take a look at halving life. Alright, so in this one it says element X is radioactive isotope such that 13 years its mass decreases by half. Given that the initial mass of a sample of element X is 60 grams, how much of the element will remain after 30 years to the nearest whole number? So you're going to figure out where you begin with, and we're beginning with 60 grams. Okay, and we know that it's decreasing by half. It's decreasing by half here. Okay, so that's how we know to use the halving formula. Alright, so you start off with 60 grams. Then it says it does that every 13 years. So every 13 years it halves. And the total number of time we're looking for is 30 years. So now we plug each one of those into the formula here. So you got y is equal to a, which is 60, times 1/2. Now, you could type in 1/2, or you could just put 0.5. Alright, and I recommend just putting 0.5 in the calculator. And then raise it to the time, which is 30 over 13. And then you type it in the calculator and you get y is equal to 12.118999608. And we want to round to the nearest whole number. So we got 2 here, the whole number. The number to the right is 1, is 4 or less, so we let it rest. So y is close to 12. This is halving formula here. Half-life. Alright, go ahead and take a look at this example here and see if you can solve this one on your own. Alright, so you should get y is close to 800. Y is close to 800 here. And this is a very good real world problem right here with cars that depreciate. Buy the car, $40,000, 17 years later it's worth 800. That's pretty cool. But basically you should get y is close to 800. Make sure you understand that they said to round to the nearest $100. So that 8 is 5 or more, so you raise the score on the 7 to get it up to 800. But that is half-life and doubling time. I want to thank you for checking out Mr. Ware's videos. Have a nice day.